All right, before we move on to the last couple examples, I need to acknowledge that I forgot to do domain and range in this problem. That's a pattern for me over these notes. But anyways, domain and range. Domain for these, for our new function, taking a look at that starting point. Let me go over to that graph and zoom in a little bit. So the starting point of that graph, it's got this starting point over here at -3, and it doesn't go any further to the left of that. So we're going to say our x's are elements of the reals as long as x is greater than or equal to -3. You are not able to plug in any value less than -3 in here. If you plugged in -4 for that x value, you'd end up with -4 plus 3, which would give you the square root of -1, which gives you an imaginary number that we haven't had a chance to talk about yet. Yes, there are such things as imaginary numbers. So we can't plug anything less than -3, but we can plug in things that are greater than or equal to -3. Our range, taking a look at our y values. Our y values, the highest point we see here is that y value of -1, and everything below that. So we're going to go y, whoa, that was bad. Let's try that again. Y is an element of the reals as long as our y's are less than or equal to 1. Every y value we can get on our graph has to be at 1 or below, nothing above it. Okay, so that's the part I forgot. My apologies. Hopefully that last video didn't throw you off. But let's talk about one last example. I'm only going to do this first one here, but I want you to take these step by step. So the first thing it asks us to do is to come up with a quadratic function that has been shifted up by 3 units, then vertically stretched by a factor of 2, and then reflected over the x-axis. So we're going to kind of just take this piece by piece. The first part we're going to do is it's a quadratic function. I'm going to call that step 1. We're going to take this step by step. So step 1, quadratic function. The parent function for that is x squared. Then it says that has been shifted 3 units up. So I'm going to call that step 2. So what we're going to do to shift that 3 units up is going to be x squared, and then we're going to add, oh, my old notes are different. 3 units up is going to be x squared plus 3. Then, step 3, we're going to vertically stretch it by a factor of 2. Vertically stretch it by a factor of 2 means we multiply everything by a factor of 2. So we're going to take the x squared plus 3 that we had, and we're going to multiply that whole thing by 2. So in order to multiply the whole thing by 2, we're going to take the 2 and distribute it to the x squared, which gives us 2x squared. We're going to take the 2 and distribute it to the 3, which gives us 6. The last part reflected over the y-axis, part 4. The reflecting over the y-axis means we're going to take the opposite of the x piece. So we're going to take this 2x plus 6, or sorry, 2x squared plus 6. We're going to take the x and take the opposite of just the x. And that's got to be in the group with x, plus 6. Now this is a perfectly acceptable version of this answer. Some of you may notice that -x squared is the same as x squared. So like this is a good version of this function. And in fact, maybe we should give it a name. So let's call it g of x. But as some of you may have noticed, -x squared is the same as just x squared. So both versions of this are correct. Let's do the last one together. I was initially planning on skipping it, but since it didn't take quite as long. So the function, we're asked to write a function h of x. So our final answer is going to be h of x. I'm going to write that over here so I don't forget. Whose parent function is a cubic function. So let's start with that. So that's step 1. Step 1, we've got a cubic. Step 2, it's been shifted up 2 units. So step 2, up 2 units means we're going to add 2 on the end. Horizontally compressed by a factor of 2. So horizontally compressed, that's step 3 here. Horizontally compressed, remember horizontal stretches and compressions, the number you're multiplying by is the reciprocal of the factor we're using. So it's going to be in parentheses 1/2 x cubed. So we got to put the horizontal things in parentheses. Horizontal stretches, compressions, shifts, and reflections. But we still have that plus 2 on the outside. And the last part it says, then reflected over the x-axis. Reflections over the x-axis means you're flipping everything over. You're going to take the opposite of everything. So in general, it would be the opposite of that whole thing, the 1/2 x to the third plus 2. Now we can make that a little cleaner by distributing the negative to both of those pieces, which would give us h of x equals negative 1 half x to the third plus 2. I would say that's probably the answer that I would be looking for. Let me shift this a little bit so you can see it. That's probably the answer I'd be looking for. There is a slight, like if you wanted to do the 1 half x to the third power and actually distribute that out, you'd end up with negative 1/8 x to the third plus 2 if you distribute that exponent to the 1 half and to the x.